Welcome to another tutorial for machine learning. So in today's video, we are going to look at how to use the particle swarm optimization algorithm for feature selection. So let's get started. So the notebook for this tutorial is available. I'll show you where to find it in a minute. It's on my GitHub repo. First, it's important we do a quick recap of what the particle swarm optimization algorithm is. So let's proceed. So when we talk about the particle swarm optimization algorithm, it's commonly referred to as PSO. So it's also an optimization algorithm, just like genetic algorithms, and it mimics the collective behavior of a group of animals, such as flock of birds or a school of fish looking for food. So the classical PSO algorithm uses a random search approach. It's bio-inspired, by the way. And so typically in the search process, the search process is influenced by two variables, which we refer to as the personal best and then the J-best. Okay, so just take note of that. So PSO is also a population-based algorithm. It's also another group of swarm intelligence. So there are several categories that, or let's say a couple of categories where this algorithm can be put into, basically. So this is how it operates. We initialize, just like genetic algorithms, we initialize the population, compute fitness, go through a series of steps, then we repeat until the stop criteria is met. Then we now use the overall best or the best search so far, the best search so far to develop our models or to proceed with our next stage of the analysis pipeline. Okay, so I will quickly show this. I think it will be a good illustration to show the PSO algorithm. So just take it this way. So this is an iteration that I did. It was based on a tutorial, by the way. So if you look at this particular diagram here, what we see is this X. So this is actually the targets. So we want to find the best search, which is this one here. And each of these is a particle, or you can also say a candidate solution. All right. So each of these, and what is happening that these particular particles here, they will be moving in the search space until they get to the best search, which is this one, the best find here. So let's play this quick animation to look at how the particle swarm optimization operates. So that's how it operates. So we have these particles moving, and they are all moving on, so they get to this particular point, which is referred to as the optimal. So several iterations are done until the end criteria or stop criteria is met. If it's not met, until another metric is used to stop it, and then that particular iteration that we end, the best find that we have, the best search we've done, that particular information becomes our best, and that's what we use. Okay, so this is how the typical PSO algorithm works. Now, in our situation, we are using it for a feature selection task, so a slight modification is needed, which I will talk about later on. So when we talk about the PSO also, I think I have some information that you can use. Let's check online. I saw these cool illustrations that you can also use to help you get started in learning it. So we have something like this. We also have a flock of birds. So if you look at flock of birds, even though they are moving in group, whenever a particular bird or some birds find some food, typically information is sent to the other flocks, and then they all change direction gradually to where they think they can find food, or where they think they will be able to do a better search or something like that. So typically that's how the PSO operates. So I have already prepared the Python code that we are going to use from scratch. So what we need to do is to get our Python environment ready and then try to follow what we have. So the notebook can be found here. I will show it here in a minute. So it's on one of my GitHub repos, which is this one here. I'll leave the link to this page in the description box. All right. And again, for those who want more information about the PSO algorithm, just check online. There are several materials that you can use to get started. There are several of them. So I will still leave some useful links that you can use to check. Or you can start with Wikipedia. That also works. All right. So that for those who want the detailed explanation as well as the principles and the concept behind them, you can do that. For us, we are only applying it for a feature selection. So that's what we need. So in this case, No need for any mathematics or any stuff. Just follow and then get it. We are only implementing what we have. Okay, so that's the Python notebook. So just download yours. There's it. PSO episode 1. I think I'll be making more tutorials on this particular algorithm. So just download this from GitHub and then use it. All right. And then make sure you also have your Python libraries installed. So I'm using NumPy, SciPy, a couple of others, random forest classifier, all those stuff. Now we are using it for feature selection. So we are going to use a wrapper approach. So with wrapper-based approaches for feature selection, we also include a classifier. So that is why here I have a random classifier that I'm going to use. So you take note of that. So I have my functions. So this reads the input files, the data, and then we generate our population. And then we also have other functions that allow us to achieve or perform those other steps that are made mention in the slides. Evaluate, get p-best, get g-best, all this. And then we do the search for a number of times, and then we end it, and then we return the best. I also have a line. So this particular function here is the main function that runs the algorithm. So it starts and runs the algorithm. So at each iteration, the best find, or let's say the best search made, is recorded, because sometimes you may need this information maybe to do some additional analysis or stuff. So I record this, and then later on it's brought as an output when you end the algorithm. So that's just by the way. So for those who also want a detailed explanation of all these codes, you can just book a session with me, and then we can work it out. Or those who also want improved version of the codes, you can always get back to me later. But for now, this one is free. Just download it and then use it as you want. Okay, so that's it. So let's proceed. So with PSO, we'll talk about it. So we need to define our input files, our data. So this is the data I'm using, the Wisconsin data, which is here. This one here. This can be found in the UCI repository. So there's the Wisconsin data set. So I have test, train, validation. So this is it. I downloaded the original data set from here, and I pre-process it to the format that I want to use. So if you want to use the original data, you also have to do some modification to suit what you want to do. That's the most important thing here. All right. So I have the data. So the data, let me just also show it, especially for those who are beginners. I will do this first. So with the data, we have 3 files. We have the train, the validation, and then the test data sets. All right. So the training and the validation, these are used for the feature selection. So with feature selection, we are looking at selecting a subset of data. Okay, a subset of the features. So these two are used, and when we are done finally, we also need to evaluate or test the subsets with an independent data. That is what the test.csv is for. Okay, so this one is not involved, or it's not used in the feature selection process, but we needed to test to make sure that whatever search we've obtained, whatever result we've obtained is actually good. Okay, so that we can use it for our downstream analysis or to build our models. So that's why we have 3 of them here. But other people will have slightly different techniques for using the data set. So just take note of that. Okay, so I also showed the data here. So there's it. There's the Wisconsin data set. There's the train data set. So I have the features which are here. Each of these columns is a feature or variable. And then the last one is the class. That's the label. You know, each patient here, each row here represents a patient or individual or a subject, depending on what your study design. But these are all measurements. So each individual here, there are several measurements that have been made, or several tests, okay, for that individual. So we have this. There are about 30 of them. So what we want to do is to rather use a subset that will give us comparative results, or that will also give us a better or comparative results than what we would have obtained if we had used the entire data set. That's what we are doing here. Sometimes all these variables or features Some of them may be noisy, some of them may actually lead to a poor performance of the model. So we use feature selection to try to select a subset and eliminate all those irrelevant ones. So that is what we are doing here. All right, so let's go back to the Python code. Okay, so what I'm going to do is to set my parameters and give the initial information. So here I have a part that tells Python where the data can be found. I have train, test, validation. I need all this information. And then with PSO, you also need to set some parameters. Okay, number of iteration, we need its population size, and they also have options here, C1, C2. So these are cognitive and then social components. We also have inertia. Now for the PSO parameters, a detailed explanation is beyond the scope of this tutorial. However, you can start with this particular book here. I will leave the link in the description box to learn more about the parameters that you use in particle swarm optimization algorithms. Okay, you can also check online. I also saw this, which I think will be good. So it explains the C1, C2. These are used to guide the search process. That's all that you need to know. So you always have to tune it for specific problems or for different problems. That's what we are doing here. All right, so I'll run the code. So yeah, so first of all, I initialize my population. I'll read the data first, initialize the population, create my classifier, set the gbest records, and then evaluate gbest, pbest, gbest, record the best find so far, compute velocity position, do it several times until the number of iterations is reached, then I return the result. That's basically what we are doing here. So these comments will guide you when we are using the Python code. Okay, so I'll run this. We need to run the functions to make sure it has been recorded, and then we can now run. Okay, so while it's running, we're also going to talk about some things here. Okay, now I'll run the codes. Okay, so when I run the codes, you get this first task, reading fast. That tells you that the files are not being read. Then it starts. So just like with the genetic algorithms that I showed here too, it records for each iteration. It gives you the best find, okay, the best search so far, and then it lets you know what is happening. So typically with these random search approaches, you have to run it for several iterations in order to get a good result. Okay, so as it's running, you also need to know that here the fitness function is the F1 score. We are trying to get the score, the performance of that subset, and that is what we are looking at here. So we are using the F1 score. All right, so the F1 score is what I'm using to evaluate the subsets because it's a machine learning task. There are other evaluation metrics, so use the one that you see fit. F1 score, I'm using it because it's able to take into account an imbalance data. It can also be used for multi-class data. So that's what I'm using it for. That's what I'm using it for. It's also popular in the field of machine learning tasks where you use medical data sets. So these are the reasons why I'm using them. But typically you can use several other metrics to make sure you have a robust feature subset. All right. So that's what you need to take note here. Okay, so it's running. I think it's almost done now. So we can see some progression here. It started with 0.94, 13 features, and then it went to 0.95, 17, and then 96, and then we have this. So here we see that in the training phase, the performance was 0.96, and when we tested it on the test data set, we got 0.95. which is almost close. So this also indicates that the result is good. Okay, so typically with the performance metric and the threshold, it's important to consult people in your domain to know what is being done, and you can use that to make a decision whether the subset selected is good, and then you can proceed. So here, from what I see, the difference is not that much between the training set and then the test set. So that means that the results are good. However, you can still run for multiple iterations just to make sure that everything is okay. All right, so that is for the particle swarm optimization algorithm. Now, with this particular code, I return GBEST records and test score. So the test score, that's what has been displayed, but the GBEST records keeps records of all the search, okay, all the best searches made so far, and then you can always use that to make plots. So for example, I have a plot here, which is the convergence plot that you can use this information here to plot. I think I'll show that here first for you to see how that is done. So here I have the F1 score and I have the number of features. So here we see that iteration 1, 0.94, and then it improves in iteration 3, and it's kind of stays consistent for some time. So this also lets you know how the algorithm is doing, and then whether it's improved over time or maybe it's performed well. So this will let you know. This is for the F1 score, that's the predicted performance. You can also use that to check the number of features being selected per iteration, okay, for the best search made at that iteration. So here we see that it starts from 21 and then it moves gradually to 17. All right. So this particular one is for a different test, by the way, but it's just to demonstrate that you can plot it. For those who also want some of these plots, you can also let me know, and then you can put that into the Python code. So these are things you do after you have made your search. There's also something important that we have to talk about. So with the PSO algorithm, what happens is that there's a representation which you need to look at. It also uses the binary representation, just like the genetic algorithm. So you represent it this way, where 1 means the feature has been selected and 0 means it has not been selected. So this is for feature selection. All right. So this is how you represent the data, okay, in particular swarm optimization algorithm. So as a matter of fact, a lot of these population-based and then bio-inspired algorithms, and the representation is kind of similar. They mostly use binary representation, but there could be other formats as well. So you need to check and then see what is used in your domain. Okay, now I talk about the PSO algorithm. It also has drawbacks. It's random set based. It comes with a high computational cost because wrapper methods typically, that's one of the drawbacks. You also need to tune the parameters, you know, the C1, C2, inertia, and then some other ones. You need to tune them. It's also susceptible to local automatic trap, and also there's the issue of premature convergence. So it's important to always improve them. What I showed is the classical PSO algorithm. So improvements, you could use search, parameter tuning. There are also those who combine PSO with other algorithms, so we get hybrids. And there are also those who use adaptive techniques. So these are things you can use to improve the particle swarm optimization algorithm. So these are things we can talk about, or for those who need some of these improvements too, you can always check with me and then we can see what to do about it. Okay, so this is for particle swarm optimization algorithm. Now, you can also test with the Parkinson's disease data as well. So all that you need to do is to change the link. So when you come to the data sets, you can just click Parkinson's, and then the link that you see here, you just put that here. Okay, you put that here, or you can even change this with the Wisconsin name here to reflect the Parkinson's, and then that will give you access to the Parkinson's data. You can also run it, or if you have your own data sets, you just make sure the format is the same and you can use that to run. All right, so that'll be all for this tutorial. And don't forget to check my other tutorials on swarm intelligence, population-based, bio-inspired, and evolutionary algorithm. So just check this playlist here to learn more. And I'll see you in the next session.